My first hero was one of those great revolutionaries of the Renaissance who cut our ties with ancient thinking and started the process that began the birth of modern science. His instruments were pretty modest, just a couple of lenses, a pendulum and a leaning tower, but his ideas were so threatening that he was put under house arrest and forced to swear that he didn't believe them. Yet those ideas were so powerful and so true that they refused to remain hidden, and they changed the way we think about the universe. That sounds pretty dramatic, but that's the sort of chap he was. Galileo Galilei.
Galileo was born near Pisa, where his father Vincenzo was a musician. Galileo became professor of mathematics at the University of Pisa, where he set himself up against the very traditional professor of physics, who, like most people, believed in the universe according to the ancient Greek philosopher Aristotle.
Wow! Just look at that view. That is fantastic. And it's a very long way down. Gosh. Aristotle didn't believe in doing experiments. He believed that logic was enough. And he said that if you dropped two things, one heavy thing and one light thing, then it was obvious that the heavy one would fall faster. For example, I've got here 2 tomatoes, one perhaps 100 grams and one perhaps 10 grams. And he said it was obvious that the big one would fall faster if you dropped them together, and what's more, that it would fall 10 times as fast. What's really extraordinary is, first, that everyone seems to have believed him, and second, that no one actually did the experiment until 1590, when Galileo said, hang on a sec, I'm going to test that. And so, according to legend anyway, he came up here to the top of the Leaning Tower of Pisa, and he leant over, and I'm going to do exactly the same thing. And he dropped them off. 1, 2, 3, go. And there you are, you see? The light one doesn't take 10 times as long, it doesn't take 5 times as long. They hit the ground at the same moment. Dropping things off the Leaning Tower was never going to be a very good scientific experiment. Partly because he couldn't be at the top and at the bottom at the same time, and partly because things fall so fast that it's very difficult to see precisely when they hit the ground. So in order to investigate the science of falling more carefully, Galileo invented a very cunning piece of apparatus to slow things down, and this is it, the slope, or inclined plane. Now, he didn't have a very good clock or watch, and so in order to check the timing, he put a lot of little bells along the slope that would sound as the ball went past. There we are. He thought that things fell at a constant speed, so he put his bells at equal intervals along the slope, equal distances, expecting to hear the sound, the pinging, at regular intervals of time. This is what he actually heard. And he thought they seemed to be getting closer together, those dings. There must be a mistake. He was sure there was an error, because he was sure things fell at constant speed, and he did the experiment again. There's no doubt the ball is getting faster as it goes down the slope. He had discovered acceleration. Galileo tried a whole lot of experiments to get his bells to sound at equal intervals of time, and this was the arrangement he finally came up with. Listen. And the way he did it was by putting his bells at distances apart, not 1 to 2 to 3 to 4, but 1 to 4 to 9 to 16 to 25 to 36 to 49. In other words, 1 squared, 2 squared, 3 squared, 4 squared, the sequence of squares.
Galileo would have known the cathedral at Pisa. It was already 500 years old when he was here. Attending Mass one day, he saw another natural phenomenon that needed a new explanation.
The story goes that Galileo was sitting here one day rather bored, and he gazed up and he saw the great bronze lamp slowly swinging backwards and forwards in the breeze, very regularly. And he wondered, what is it exactly that determines the time of swing of a pendulum? A pendulum is actually a very simple machine. It's just a heavy weight on the end of a string. And there are only 3 things that could possibly affect the time of the swing. the size of the weight, the size of the swing like that, a big swing or a little swing, and the length of the string. It has to be one of those things that controls the time.
So, let's do Galileo's experiment. The heavy tin weighs 20 times as much as the light one, but they swing completely in step, so it's not the weight.
What about the size of the swing? I'll try that by making the big one swing just a little bit, and the little one swing a lot.
No, even though the small pendulum swings much further than the big one, they pass the centre at exactly the same time, so it's not the size of the swing. Finally, the length of the string. That's it! At last they're out of step, with the short pendulum much faster.
So what determines the time of the swing is simply the length of the string.
Unsurprisingly, in 1592, Galileo's contract at Pisa was not renewed, probably thanks to the Aristotelian professors. He got a chair in Padua, where he remained for 8 years. Padua was much more tolerant of his views, and Galileo made huge advances in science and enhanced his reputation so much that in 1610 he could return here to Florence as mathematician and philosopher to the Grand Duke of Tuscany.
So what had he done that got everyone so excited? The answer is he turned the universe inside out. In 1608, a Dutchman called Hans Lippershey had taken out a patent on a device to make distant objects appear closer. It came to be called a spyglass, and so Galileo decided to make his own. And the way he did it was to take two lenses like this. And then I'm going to line up on the cathedral down there, known as the Duomo, and there I can see very distinctly the striped ribs of the dome coming up and the ball on top. Terrific. Magnification must be about 8 times. But what use was it going to be to Galileo? Well, in 1610, he pointed his telescope at the sky.
The results were completely at odds with what people thought about the universe. He looked at the moon and was amazed to see that it was not a perfect sphere, as he had been taught, but rough and mountainous.
The trouble really came when he looked at Jupiter. Jupiter is usually the brightest thing in the night sky after the moon and possibly Venus. And what he saw was a great round ball, imagine it's my head, and then on one side of it there were two little dots, bright points of light here, and 2 points on the other side. So altogether, 4 bright points of light. And he thought maybe they were stars, but they looked very close to Jupiter. He looked again a couple of nights later, and this time there were 3 on one side and only 1 on the other. And he looked again and again, and these 4 points were definitely associated with Jupiter and moving backwards and forwards, and he realized they must be actually going round the planet Jupiter.
With his telescope, Galileo began to build up evidence that the planets went round the sun, not the Earth. It was an idea that had been suggested by Nicholas Copernicus in 1543. This now set him against the Church, which supported the Earth-centred universe of Aristotle because it seemed to be described in the Bible. In 1616, Galileo was denounced for going against Holy Scripture. The works of Copernicus were withdrawn while certain corrections were made, and Galileo was instructed not to believe or defend the idea of the Earth going round the sun. How could he continue as a scientist?
He went quiet for a while, and then he worked out what to do. He sat down and wrote the most wonderful book, a dialogue on the two world systems. And he put out all the ideas in the form of an argument between two advocates, one chap speaking for Aristotle and the other for Copernicus, each of them trying to win over a third person, an educated layman. In this way, he hoped he wouldn't be seen to be supporting either side. A few copies were circulated, and then instructions came from Rome that they should stop printing or selling copies, and Galileo was summoned to appear in October before the Inquisition. The result of the trial was never in much doubt. The Vatican had no trouble at all in proving that Galileo was guilty of heresy, having held a view that was against Holy Scripture. His specific crime was in saying that the sun is at the centre of the world and does not move from east to west. The punishment was absolutely extraordinary. He was condemned to life imprisonment, which at least they quickly changed to permanent house arrest, here in his villa at Arcetri. And perhaps worst of all, he was forced to abjure. I abjure with a sincere heart and unfeigned faith these errors and heresies, and I curse and detest them.
The Catholic Church finally apologised and withdrew their condemnation in 1992, 360 years later.
Eventually he died here in this house in 1642, the year that Isaac Newton was born.